Hello, welcome to my screencast on building a web application using ASP.NET Core 1.0, Aurelia, TypeScript, and Webpack in Visual Studio Code. Wow, such a long name. But these are all the tools and technologies that I'd be using to build this web application. This is the part one of a series of screencasts. Who am I? My name is Rajamani, and that's me. I live in San Jose, California. I'm very passionate about technologies, and I've been coding since 1988. I blog in opensource.netter.blogspot.com, and this screencast is actually a complement of the series of blog posts that I'll be posting in opensource.netter.blogspot.com. Microsoft and open source software development. Are we kidding? We thought Microsoft is a proprietary software company. Gone are those days. It is very exciting to see Microsoft developing their .NET platform, libraries, and languages out there in GitHub as open source. Here's a list of software repositories that they have. It's very impressive, isn't it? What is ASP.NET Core 1.0? What is the need for this? What happened to the ASP.NET 4.x? Well, we all know that ASP.NET 4x was built on system.web.dll, which is a monster library. ASP.NET Core is a lightweight and a complete ground-up rewrite of ASP.NET. It's based on a set of granular and well-factored NuGet packages. As you all know, NuGet is the package manager for .NET. So you only use what you need instead of getting everything at once. Node.js and NPM, what has that to do with Microsoft open source? Well, Node.js has taken JavaScript to the server side, and that has opened up a lot of possibilities for people to write server-side software using JavaScript. And NPM, it's an acronym for Node Package Manager. That is the package manager for JavaScript, period. If you look at any popular JavaScript libraries, these days they host their library in NPM so you can install it. Just like how NuGet is a package manager for .NET, NPM is the package manager for JavaScript. ECMAScript 2015 and 2016. What is ECMAScript? It's just a standards body. They define some standards for a language called ECMAScript. It's been implemented by JavaScript and JScript from Microsoft, but it's no longer actively developed. So everybody's is using JavaScript or developing JavaScript. When we say ECMAScript, we're talking about JavaScript. So the current standard is ECMAScript 5, but we've already seen the specifications being finalized for ECMAScript 2015. It's also known as version 6 or revision 6, and ECMAScript 2016, which is called ECMAScript 7. So these are the standards, and not all browsers are there yet. So what do we do until the browsers catch up to these technologies? That's where we have transpilers. And one of the languages is TypeScript 2.x from Microsoft. TypeScript is not another language. It's basically a typed superset of ECMAScript. JavaScript is typeless, as you all know, whereas TypeScript introduces the concept of types on top of JavaScript. So TypeScript is nothing but a JavaScript with types. What happens is you need to write code in TypeScript, and then you need to convert TypeScript back into JavaScript. And then you use the resultant JavaScript in your application. They say it's a type superset of JavaScript that compiles to plain JavaScript. Any browser, any host, any OS, open source. And that's true. You can run TypeScript on OS X or Linux or Windows. What is Webpack 2.x? Webpack is a module bundler. Modules are very important when it comes to client-side development. Remember when we used to develop in ECMAScript 5, we used to have script source equals a particular JavaScript file. And then what happens is A depends on B, B depends on C. Over a period of time, you're going to be seeing a lot of script source tags in your application, and even the original developer will forget what depends on what. And that's like a nightmare. So modules and module bundlers are really going to help us by grouping the modules and then like minifying them and delivering them on demand. There are quite a few build tools out there. There are quite a few minifiers out there, but Webpack is very unique because it not only is introducing the concept of modules into JavaScript, but also to the static assets like PNG, CSS, and so on. Visual Studio Code 1.x. What is Visual Studio Code? Is it the same as Visual Studio? Absolutely not. Visual Studio Code is a ground up rewrite, and this is the lightweight editor slash IDE. I wouldn't call it a full-blown IDE because it is not, but it is very lightweight and it is cross-platform and it can run applications written in C Sharp, JavaScript, TypeScript, and whatnot. And people have written third-party plugins for Python, PHP. So Visual Studio Code 1.x is being adopted pretty rapidly now. .NET Core 1.0 SDK. Why do we need that? Of course, ASP.NET Core 1.0 is built on top of .NET Core 1.0. If you want to develop any ASP.NET Core application using Visual Studio Code, you need to first install .NET Core 1.0 SDK, and that's available in this URL. And you can download this .NET Core SDK for Windows. If you're using Windows and if you're using Linux or Mac or Docker, you'd be clicking on these tabs and then you will download the appropriate installer. We're going to be using Windows. Commander. What is Commander? Why can't we use the command.exe that ships with Windows 10? It's very old. It doesn't support copy paste easily. You need to right click and you need to paste. There are so many quirks in command line exe application that ships with Windows 10. Commander is a console emulator which is more powerful, and you can download it from commander.net. Of course, node.js, we already talked about it. We need node.js because we need Node Package Manager, and this can be downloaded from nodejs.org/en. And there are two versions. One is 4.4.7 LTS, the other one is current. I am going to be using v6.2.2 current, but you can choose to use 4.4.7 LTS. Both of them will work. Visual Studio Code v1x. Actually, it's version 1.2 right now. You can download it from this URL right there. And since I'm using Windows, I will be downloading it from this URL and this link. We cannot do anything much with out of the box VS Code, so we need the extensions. And somebody like to call it plugins. They are the same. And the first plugin that we are interested in is C Sharp plugin. It's from a vendor called OmniSharp. And you could go to the URL and download that installation, download that plugin. We also need the TypeScript linter. You can download it from this URL. Now let's dive right into the demo. Okay, so we're going to be starting from the commander. First thing I want to do is I want to create a tutorial folder. So I'm going to call it tutorial. And since this is part 1, I'm going to create a folder named tutorial part 1. And then cd into that. Once you're inside the folder, we're going to install a few packages and few tools that are required for us to write ASP.NET Core application. So what I'm going to do now is I'm going to install a few packages using npm, which is Node Package Manager. The first package package that I want to install is Yeoman. Yeoman is a code scaffolder, or you can call it code generator. It generates code for any particular technology. You can choose different generators. The generator that we are going to use is ASP.NET Generator. So the command for that is npm install -g yo generator -ASP.NET. Since I've already installed this dependencies, which is Yeoman generator and generator ASP.NET, I'm not going to install them again. Once you install it, what you can do is you can run Yeoman generator to generate an ASP.NET application. It ships with a few generators. Let me just start the generator by typing the command yo ASP.NET. And it's going to give me a menu with a few choices. And I'm going to be picking the empty web application. So as soon as the menu show up, I'll pick the empty web application. As you can see, you could navigate them using using your arrow keys in your keyboard, up arrows and down arrows. I'm going to select empty web application and hit enter. The name of the application that I want to give is modern. And now it went ahead and created a few C# files, a JSON file, web config, Docker file, README, and so on. So now they've also given some instructions, like you can change the directory to that name of the project, which is modern. Then you can run the .NET CLI, command line interface tool called .NET. .NET Restore will restore the packages in project.json. .NET Build will build it, and .NET Run will run it. Since we're going to be using Visual Studio Code, I'm not going to be doing that from the command line. But what I'll do is I will switch to that directory. The directory is my project. So we no longer need vcproj and all those project files. So if you switch into the directory that you created, that directory is your project. Now I'm going to launch Visual Studio Code. In order for you to launch Visual Studio Code, you can type code followed by the folder that you want to open. Since I'm going to be opening the current folder, I'll type code space period, enter, and that's going to open up Visual Studio Code. I'm going to dock it to the left side of the screen. Since the font is too small, I'm going to zoom it up a little bit by pressing Ctrl++ a few times. Okay, now as soon as you open up, it's going to give me some help. It says required assets to build and debug are missing from your project. Add them. Yes, close. Why not? Let me click yes. And watch over here. It's going to add a folder named .vscode. And inside of that, you're going to have two files named launch.json and tasks.json. Let me open up launch.json. It's again a JSON file and it has a few parameters. The thing that really interests us is the program that it needs to run when you try to run it from within Visual Studio. As you can see, the workspace root is nothing but the folder from where you launched Visual Studio Code, and it has some subfolders: bin, debug, netcore app 1.0, and modern.dll. This is going to be the assembly that it's going to create after you build the project and you run it. So for now, that's enough if you understand that what program it's going to launch. And tasks.json is Visual Studio Code file again. It is going to invoke the .NET command and the build. So as you know, that's going to be the command that you want to use to build a ASP.NET Core application. And if you notice the launch.json, it is going to launch the browser automatically by using this command exe and then the URL. When you do a command exe followed by an URL, whatever the browser that is associated with the URL will launch. In my case, it's going to be Chrome. Whatever the browser that you associated, that's going to be launching your application. Okay, so let's go ahead and look at some other files in this project folder. Program.cs. We have seen program.cs in console applications and Windows Forms and WPF applications. Why would a web application have a program.cs with an entry point named main? Very good thought. ASP.NET Core has decided that it's going to run on multiple operating systems and it's going to be cross-platform. So it needs an entry point. So they decided to choose main as their entry point, and there they configure a few settings and then they launch the web host builder. And if you can see, we have a new web server named Kestrel, which is a very lightweight web server. You no longer need IIS and you no longer need it. It's going to be very lightweight and you can just run it, and then it's going to launch Kestrel and it's going to start serving your static files, your MVC pages, your web API, whatnot. Then let's go into another interesting file called startup.cs. As you can see, there are two important methods here: config services and configure. The configure services, as the name implies, is where you will configure services like MVC and a few other services. This is also the function or method where you will be injecting your dependencies, because ASP.NET Core has DI, dependency injection, everywhere. Then the next interesting method is configure. So after you configure the service, you need to use them. The place where you use them is inside this configure method. Let's take a look at what Yeoman has generated for us. All it did was it created a middleware. A middleware is a fancy name. It just think of it as you could have a pipeline, and you can write middleware after middleware after middleware. You can stack them up. For example, authentication is a middleware, authorization is a middleware, and you can put anything you want, and you can write anything you want as a middleware, and you can call app.run with this syntax. In this scenario, all that it does is it writes a simple hello world string into the response stream. Okay, then now that we've looked at everything, let's look at this project.json. This is the final file. Like I said, we don't have project files, but project.json is kind of like your project file. It tells me what all assemblies that my application depends on. As you can see, it has the name of the assembly, colon, the version. If you were to use Visual Studio 2015, and if you go to manage NuGet packages, and if you start adding the packages as references, instead of adding them into the file vcproj or whatever, it will directly write them into project.json. So if somebody else wants to take this source code and run it on Mac OS X or Linux, they will not have Visual Studio because Visual Studio does not exist on those platforms, but they'll have project.json file, and they can use the command line .NET CLI tool to restore and then run the application. Okay, then now how do I run this application from within Visual Studio Code? You can click on this debug icon toolbar, and as you can see, it gives you a choice: .NET Core Launch Web, .NET Core Attach. We're going to be choosing .NET Core Launch Web, and this is your favorite button, which is F5 to start debugging. This is the same thing that you used in Visual Studio as well. So let's hit that and see what's going to happen. It's going to launch the browser. Let's ignore this warning for now. I'll explain why we get this warning, and I'll also show you how to fix that. Okay, so it's on my other screen. I'm going to bring it up to this screen. As you can see, it did display the message hello world into the response stream. Okay, then what was the error that we were getting? Let's take a look at that error now. Let's stop debugging. Let's go back. You can collapse this. You can expand or collapse the file window or pane so we can have more workspace. And then let's scroll up and see that error. It says could not load symbols for modern.dll, and the path of the PDB file is a Windows PDB. So the problem is out of the box project.json always creates the PDB that is targeted for that platform. But what we need is really a cross-platform PDB or portable PDB. How do I create a portable PDB? It's very easy. We need to add a small entry inside of your project.json. Here's how you do that. Let's go scroll down to the build options, and then we're going to type debug type. As you can see, all these JSON files inside Visual Studio have IntelliSense support. So you can tab out, and then it says portable is one of the choices. So that's what we need. So let me save this and hit F5 again. But before I do that, the whole idea of creating a PDB is for enabling debugging, and one of the major features of debugging is setting the breakpoints in your code. So let's go into our code file, program.js, and then what we'll do is we'll put a breakpoint in this line number 20, and we'll also put a breakpoint on startup.cs as well. How about we put a breakpoint inside this call? Now let's hit F5 and watch on the right side, it's going to open up another tab, because every time you hit run or F5, it's going to follow the commands in your tasks.json and the launch.json. So it's going to first compile, and then it's going to launch a new browser because it's going to run command.exe with the URL. This is an annoyance with Visual Studio Code. In the later parts, I'll show you how we can overcome this. For now, you can see that it hit the breakpoint, and I'm going to click go. Now it's going to hit the other breakpoint, and as soon as you hit go here, you're going to see your string hello world displayed on the screen. Well, that's cool. We were able to run an application using Visual Studio Code, but this is not really what we've learned all these days. We need to have MVC framework, we need to have web API, and so on. How do I add all of those? Well, again, we had to use our new friend Yeoman to generate those controller classes. Okay, let's do that. How do I add MVC into my application? Let's go to Yeoman, and then we'll ask if ASP.NET has any sub-generators. To look at the possible sub-generators inside the main generator, you type yo, name of the generator, and you type dash dash help, and you hit enter. Oh, we have quite a few sub-generators. The ones that are really interesting for us are the MVC controller and the MVC view, because that's what we want to do next. So let me copy this and hit enter. So it goes to the clipboard. Before we do that, people who have been using ASP.NET MVC for quite some time knows that MVC is a conventions-based framework, which means it expects certain folder structures and certain file naming conventions. So for MVC, we need the controllers and views, which means that they need to be in the folders controllers and views. So let me go ahead and create a folder named controllers. So one of the things about VS Code is you have to be careful about where you are, because if I click create folder now, it's going to create a folder under .vs Code. I don't want that. I want it to be at the same level as other folders. So I'm going to click on one of the files and I'll click create a folder and I'll call it controllers. I also need another folder named views. And we know that by convention, the controllers, whatever is the name of the controller, for example, if my controller's name is going to be home controller, I need to create my views under a subfolder which has to match the name of the controller without the word controller. So I'm going to start with the home controller. So what I'll do is I'll create a subfolder named home under views. Okay then. Now that we've already copied the command, yeoman command, subgenerator command into the clipboard, I'm going to paste that command and I'm going to call my controller as home controller. So if you watch, it's going to create a controller named home controller. Let's open it up and see that. Cool. Similarly, I want to create a view and the name of the view is going to be index.cshtml. So I'm going to create a view using yo ASP.NET colon MVC view followed by name of the view. Okay, so let's call my view index. There's one minor thing that you have to be careful about. What's going to happen is it's going to create the view files, that is the CSHTML files under views folder. But remember, it needs to be under the name of the controller folder. So I'm going to drag this and drop it into the home subfolder underneath the views. Okay, now, as I said, ASP.NET Core is very lightweight. You only import the packages that you need or download the assemblies that are absolutely required for any feature. Since MVC is a feature, we need the assemblies that implements the MVC specific methods and APIs. So let's go to project.json, and the way you're going to add that is we're going to be adding the MVC ASP.NET Core MVC assembly as a dependency. So Microsoft ASP.NET Core.mvc, and the version is going to be 1.0.0, and that's it. Now let's go and check what's inside the view. Let's go to the index.html. It's not doing anything, which is not useful. So I'm going to just add a tag and I'm going to just say hello world from ASP.NET Core 1.0. Okay, earlier we looked at two methods in startup.cs. One is called configure, the other one is called configure services. Since MVC is a service, we need to configure the service first. So it's going to be services dot add MVC, which is an extension method. So we have configured our service, but how do I use it? To use the service, you have to call use and the name of the service. That's the convention. App use MVC. And it's going to take a lambda expression, and that's going to look like this. Routes dot map route, and that takes two parameters. The name of the route, you can name it anything you want, but I'm going to call my route as default route, and then the template that you use for the URL. So the template syntax is going to be the name of the controller. If no controller is provided, it's going to default to home slash the name of the action. If no action is provided, it's going to default to index action and an optional ID parameter. An optional parameter ends with a question mark to indicate that it is optional. And let's see how to close them. So here's my closing parenthesis. And then we also need to close the other one. So now that everything is closed, you don't want to run this response.write async, which is going to display the hello world string because we already have wired MVC, and MVC is going to look for a controller name home and action if you don't give the controller name and an action name in the URL. So I am going to remove this breakpoint and comment this line by pressing Control KC. Okay, now let's hit F5 and see what happens. It's going to launch Chrome and open up another tab, and it has to display whatever we gave in index.chhtml, which is going to be a hello world from ASP.NET Core 1.0. Okay, it's hit the debugger. Let's get go, and then it's going to launch tab, and then it's going to load home/index. You can also explicitly give the controller slash action. So that's also going to do the same thing. That's cool. Now, what we're going to do is before we wrap up this part, I want to show how you can write an ASP.NET Core Web API. So let me stop the debugger. For Web API, you don't need to add any more dependencies. Unlike in ASP.NET 4.x, they've integrated the API controller and the controller into MVC. So you no longer have to add a special dependency for Web API. When you say you've added MVC, you automatically get Web API. Okay, then let's create a API controller using Yeoman. As you can see, there is a command subgenerator for Web API. It's called Web API controller. So let's copy that and let's paste it over here. And we want to call our controller greetings controller. As soon as it's generated, let's open up the controller inside the controllers folder, and then we'll clean up the unwanted code. Pretty much I'm going to delete every stub method generated by Yeoman, and all I want to do is just return a string from this API. And that is going to be hello world from ASP.NET Core 1.0 Web API. Let's save this, hit F5, and once it hits the breakpoint, we'll give go, and then it'll open up a new tab in the browser. Then we will navigate to /API/ the name of the controller. As you can see, the route for Web API is slightly different, but it still uses the same controller base class, as you can see from here. So once it launches the debugger, it's going to hit the breakpoint in our program.cs, and we're going to hit go, and then we will be able to see the output from that controller. Okay, then let me remove this breakpoint because it's really annoying. I'll make it run. I was going to load the home index, but in order for us to reach the API, we're going to give API/greetings, and there it goes. That concludes the part one of this series. Until we meet in part two, happy coding. Thanks.